Greetings. I'm Randall Carlson, your host of Squaring the Circle. I'd like to welcome you back to another episode. And in this episode, we're going to start talking a little bit about cosmic catastrophe in the age of Leo. And some of you may know the age of Leo as the Younger Dryas, or at least part of the age of Leo occurred during the duration of the so-called Younger Dryas. Interestingly, the beginning of the so-called age of Leo and the beginning of the Younger Dryas occurred within 50 to 100 years of each other, maybe even exactly at the same point. Of course, what I mean by the age of Leo before we get started is simply the time during which the spring equinox was transiting through the star constellation of Leo the Lion. I don't mean to imply any particular significance to that other than it just simply provides us with a chronometer by which we can actually correlate things in the sky with things on the earth. And during that period of time, from about 12,960 years ago for about the next 2,000 years, the vernal equinox was moving through the star constellation of Leo. Let's just begin here by going back almost 3 decades. It was kind of a milestone for me because I was invited to give some lectures. And so in March of the year 1996, I gave a series of lectures at Warren Wilson College in Western North Carolina. One of the themes of these lectures was the growing massive evidence for a major global catastrophe occurring somewhere around 13,000 years ago that wiped out many of the species of great megafauna that inhabited the Earth at that time, and had done so for hundreds of thousands of years. By the 1990s, when I gave these lectures, the evidence for catastrophic change events in Earth history was quite robust and well substantiated. Since the early 1980s, the majority of mainstream Earth scientists were accepting the idea that something profoundly catastrophic happened 65 million years ago or so that ended the reign of the dinosaurs. By the early 1990s, the majority of mainstream Earth scientists, geologists, paleontologists, and others were accepting the idea that the catastrophe involved, if it was not triggered by, the impact onto Earth of a giant asteroid. The acceptance of this radical idea came about as the result of the discovery of the giant buried Chicxulub astrobleme or star wound in the area of the Yucatan Peninsula, Mexico. But it also appeared that massive volcanic eruptions severely affecting the global environment occurred at this time as well. So there was a controversy between the impact camp and the volcanism camp as to which one played the greater role in contributing to the ultimate extinction of the great dinosaurs. So, however, I would maintain that it is not unlikely that the volcanism may have been triggered by the impact, or if the volcanism was already underway, it may have been intensified by the impact. Interestingly, Chicxulub impact site in the area of the Yucatan is at the antipode of the source of the outpouring of the vast Deccan Traps lava floods that form the igneous province now comprising a large part of western India. Every spot on Earth has an antipode, or I've heard it's also pronounced antipode, but I think antipode is the more correct one. But every spot on Earth has an antipode, which is the point on the exact opposite side of the sphere. The idea here is that the tremendous shock wave generated by the powerful impact in the Yucatan would have traveled through and around the Earth's crust, converging on the exact opposite side of the planet with extreme force. In other words, the impact may have triggered the volcanic eruptions, which would have then added to the mayhem on Earth at that time. At this point, I think it was both the volcanism and the impact working together that really clinched the severity of this mass extinction event. And now, since the confirmation of at least one great impact event at the Cretaceous Tertiary or KT boundary, as we used to call it, now it's the K/PT boundary. Since the confirmation, it had provoked one of the most severe mass extinction episodes in Earth history. A considerable body of evidence has accumulated pointing to the conclusion that catastrophic impact events may have occurred with alarming frequency over time, and in the process have generated extreme climate and environmental changes and associated mass extinctions that accompany destruction of habitat. There have been 5 recognized, maybe 6 now, depending on whose data you're looking at, but there have been at least 5 recognized great mass extinctions since the dawn of life on Earth, in which a majority of species existing at the time were abruptly killed off. Each of the Great 5, which demarcates some of the major geological boundaries, has suggestive evidence pointing to the occurrence of cosmic impact at or near them. The greatest mass dying episode in Earth history is at the Permian-Triassic boundary of 245 million years ago. This event, or events more likely, came close to killing all life on Earth. It appears to have involved both cosmic impact and immense volcanism. The so-called Siberian traps, which is another great igneous domain on Earth, up in Siberia, seems to be associated with this particular geological and paleontological boundary. There have also been innumerable lesser extinction episodes that have decimated significant numbers of species, including the geologically very recent terminal ice age extinction that has the unique distinction of having occurred in the time of modern humans on the Earth. By the time I gave those lectures in 1996, my interest had already turned to the question of what role catastrophic events have played in human history. This idea had been an obsession of mine since the 1970s, when I began to believe that many of the striking parallels found throughout the world's great mythical traditions had behind them the memory of actual events. Especially was this true with the traditions of world destructions by giant floods and fires. I'd also, as a boy, been obsessed with dinosaurs well up into my teenage years. I'd been exposed to the idea of a catastrophic end to their reign on Earth through the medium of a popular toy of the 1950s. It was called the Viewmaster. This was a plastic viewer that allowed one to see images in 3D. I can still remember well receiving a Viewmaster as a present for my 5th birthday. Included with it was a set of 3 reels illustrated with scenes from the 1956 documentary Animal World, a Warner Brothers movie that contained an extensive sequence of stop-motion animations of dinosaurs during the Mesozoic era. Now, the Mesozoic, I will mention, is the great era of middle life, Mesozoic. Meso means middle, zoic means life, and it came after the Paleozoic or old life and preceded the Cenozoic or recent life. So the Mesozoic, the end of the Mesozoic coincided with the end of the Cretaceous period, at which the dinosaurs were killed off. So significant was and far-reaching was of this event that a whole great life era is now considered to have come to an end. Anyways, back to this Viewmaster reels that I had when I was 5. This one particular one that was illustrated with the scenes from this movie, The Animal World, the sequence about dinosaurs ended with scenes of the destruction of the dinosaurs in a fiery catastrophe. The booklet accompanying the Viewmaster describes the climactic scene, which follows a battle between a Tyrannosaurus Rex and a Triceratops. Now, Triceratops, you remember, is the 3-horned with the great shield and so on. You might remember if you saw the original Jurassic Park movie, there was an ailing Triceratops in there that the heroine was going to try to nurse back to health or something, if I remember right. But anyways, that was a Triceratops. So now in this great battle, the Triceratops has already delivered one blow with one of its great horns, wounding the T-Rex. But before it can deliver the killing blow, and I quote from the little narration it came with it, "A booming roar shook the air, and the very sky caught fire. Even the battling monsters froze in the middle of their fight. The earth under their feet rose and fell like the waves of the sea. The blue of the sky had vanished in a blood-red deluge of light, and the silence was broken by the booming of vast explosions in the distance. Mountains blew their tops. Flowing lava engulfed many dinosaurs, and ashes killed the plants to starve even more. Great cracks opened up in the ground. The doom of the dinosaurs was at hand. Winter came back into the world. In the cold, the dinosaurs grew sluggish, and many perished." Unquote. Interestingly, now they don't mention a cosmic impact by specifically, but yet all of the secondary consequences of such an impact are very similar to what is being described here, even to the fact of the winter, the so-called cosmic winter coming into the world in the aftermath of a great impact. So the scenario now for the extinction of the dinosaurs is, yes, the initial impact would have caused a major die-off. The secondary fires produced by the fallback debris would also trigger more deaths, but then the canopy of dense soot and material from the great fires and so on, and the material injected into the atmosphere from the impact itself, would have caused a veil to surround the Earth, a canopy, if you will, that would be reflecting the sunlight back into space, causing the world to plunge into a cosmic winter. So this particular narrative finished by raising a question that continued to marinate in my brain for decades. Quote, "The total disappearance of the dinosaur is one of the great mysteries of all time. Their complete extinction cannot be explained. This whole race of reptiles, which dominated the face of the earth, its waters, and its atmosphere for 100 times as long as the short span of man on earth, this whole race died out, leaving not one single descendant." Unquote. So, when the news came out in 1980, scientists had found the fingerprints of a cosmic event at the very boundary that marked the sudden disappearance of the dinosaurs, I was instantly captivated. The evidence came in the form of iridium, a platinum group metal that is rare in the Earth's crust, but abundant in meteors and asteroids. This discovery led to a controversy that raged over the next decade, with critics arguing for a less catastrophic, more protracted extinction event than would be implied by the sudden violence inflicted upon the planetary environment by the impact of a large asteroid. However, as scientists continued to examine the KT boundary, as it is called, or at least was called then, they repeatedly encountered the presence of abundant iridium along with other evidence of impact. Based upon the amount of iridium deposited worldwide, it became possible to estimate the size of the impactor or bolide necessary to deliver that quantity of iridium to the biosphere. It turned out that the object would need to be about 6 miles in diameter. This makes the KT cosmic object roughly 9 or 10 million times the volume of the Tunguska object that exploded over Siberia in 1908 with the force of a 15-megaton nuclear bomb. The power of an impact on this scale is unimaginable. It would literally have set the sky on fire, produced global earthquakes likely, and volcanism, produced extreme acid rain, and would have been followed by a temporary but intense cosmic winter due to the sheer volume of dust and soot injected into the atmosphere, blocking the sun. The scenario that evolved through many interdisciplinary studies as to the environmental effects of the KT impact was not at all unlike the vivid description in my little Viewmaster toy story that so captivated me way back in 1956. However, even as indirect evidence continued to mount throughout the 1980s in the form of impact proxies supporting the idea of an abrupt demise of the dinosaurs and a global ecological breakdown at the same time, critics refused to admit the possibility of cosmic impact without a smoking gun in the form of a crater, an impact crater. This changed, however, in the 1990s with the discovery and confirmation of a giant astrobleem or star wound buried under the Yucatan Peninsula that was of the right size and the right age. At this point, many of the critics were convinced. As studies continued on the extraordinary events at the KT boundary, it is beginning to appear that for a period of time, the Earth was undergoing multiple impacts during an episode of clustered bombardment, though the Yucatan strike appears to have been the most severe. It is also important to appreciate the fact that the Earth was, at the same time as this bombardment, undergoing, as we talked about, one of the largest, most extreme episodes of volcanism in the history of the planet, during which the so-called Deccan traps were extruded. So the traps are a massive deposit of layered flood basalts, originally covered as much as 600,000 square miles of lava that were up to 6,000 feet thick and encompassed as much as half of the subcontinent of India. Is it possible that the great eruptions, such as the Deccan traps, were triggered by the impacts of asteroids and or comets? This is a question that still needs to be answered, but it is almost certain the rapid extinction of three-quarters of all animal and plant species extant at the end of the Cretaceous period, including the dinosaurs, both marine vertebrate and invertebrate species, terrestrial plants, fish, insects, and primitive birds and mammals, was the result of both phenomena of cosmic impact and massive volcanism. When scientists talk about proxy evidence, they are referring to evidence which indirectly supports or confirms the hypothesis being tested. In the case of an extraterrestrial impact, this might be the increased presence of platinum group metals, such as iridium, osmium, or platinum itself. It can also take the form of nanodiamonds, that is, tiny microscopic diamonds that are formed in the extreme heat and pressure of an impact. Other microscopic level impact proxies include magnetic grains, microspherules, carbon spherules, soot, shocked quartz, and fullerenes. Mesoscale proxies, that is, material that can actually be held in the hand and seen with the naked eye, include tektites, melt glass, shatter cones, and sometimes pieces of the object, the impacting object itself. Shatter cones, I will mention, form in limestone rock as the shock wave passes through the rock, and it gives a very distinctive conical-like formation within the rock. Tektites are formed, they're exotic, aerodynamically formed objects that crystallize out of the fusion of melted, vaporized asteroid or comet material and the target rock as it falls back to Earth in a type of fiery alchemical marriage of celestial and terrestrial. So the impact vaporizes, melts and vaporizes. It adds its material to the target material, the terrestrial rock. This chaotic stew is mixed together, thrown up into the atmosphere, and when this stuff rains back out, it assumes a variety of aerodynamic shapes, and the composition of these forms is typically both the impactor itself and the target rock, melted and fused together. So the surface of the Earth is vaporized and melted along with the cosmic object itself, and an enormous amount of material is thrown out of the hellish cauldron of the crater into the atmosphere. As the molten material descends, it crystallizes, taking a variety of shapes such as spherules, teardrops, dumbbells, tubes, and flying saucers. Georgia, the state of Georgia in the USA and the southeastern United States were blanketed by one of these cosmic torrents of molten material raining from the sky when an asteroid about 3 miles wide slammed into the eastern seaboard in what is now Chesapeake Bay about 35 million years ago. This impact, which left a crater more than 50 miles wide, very nearly marks the end of the Eocene epoch and a major turning point in the history of life on Earth. Tektites found in Georgia are called Georgiites and are found where the Eocene-Oligocene boundary is exposed at the surface. Just south of Macon, Georgia, along the so-called fall line, the Eocene surface is exposed, and if one knows where to look, tektites can sometimes be found after a heavy rain when they wash out. Now, at the time, you have to picture when this stuff is raining down on the Earth, the surface of the Earth, the landscape that was receiving all of this material, of course, is not the landscape any longer. Typically, it's going to be many feet underground. And so at the fall line, you have a slope, and heavy rains will cause the layering going back 35, 40, 50 million years to get exposed. And right where that Eocene-Oligocene boundary is, there will be tektites laying on that surface that is now buried. And sometimes if you're there right after a heavy rainfall and the slope surface has eroded, you will sometimes find Georgia tektites. There is a display of them, or there used to be anyway, at the Fernbank Science Center near here in Decatur, Georgia. And they've got a very nice display of the Georgia tektites there. The occurrence of only one proxy at a particular site is not going to be enough to prove the occurrence of cosmic impact. However, when several occur in conjunction, it is strong evidence of an impact having occurred in the vicinity. In the case of multiple KT boundary proxies, they have been found on a global scale, signifying the magnitude of that particular event. Much closer to our own time, the major turning point in Earth's transition out of the Great Ice Age occurred very close to 12,900 years ago at the so-called Lower Younger Dryas boundary. This boundary coincides with the final extinction or the near final extinction of the great megafauna, the disappearance of the North American Clovis culture, and abrupt climate and environmental changes that have been documented from around the world. We're taking a little bit of a detour here to tell a story that I think is going to be valuable concerning something that recently happened to me. Oh, and I see I'm being joined by my friend and colleague, Mike Robertson.
Hello, Randall. How are you?
I'm doing very well, thank you.
Well, regarding this little story we're going to tell, we won't take too long. We'll get back to the episode shortly, but I understand you were in a conference recently in Florida, was it?
Correct, yes, in Florida, in a
And
beautiful hotel, the Fianna Hotel, I believe it was.
excellent.
Yes.
And what something happened there? First of all, how was the conference? But then I
The
understand.
conference was great.
Okay.
The hotel was awesome. But yeah, everything was good, except I was coming down the stairs, and I think somebody just ahead of me had spilled a little bit of something. It was, crowds moving up and down, and I think somebody spilled a little something on one of the treads in front of me, and my foot hit it and slid out from under me, and I tumbled down 3 or 4 stairs to the bottom.
Whoa.
I survived, as you can see. Look, I'm still here and I'm intact.
No
I didn't
broken
break any
bones?
bones. No broken bones, but I sure banged up my left knee. That was the first thing that hit. My left knee hit that tile floor. And it was painful, but I had to go. I was actually on my way to do a presentation, so I had to tough it out and go do a presentation with my throbbing left knee. So anyways, got done with that, and then as the day progressed, my knee began to swell up, and it got quite painful. And I was very relieved to remember that I happened to pack my CBD from the gods salve, and I was really grateful that I had remembered to do that. So that night I put some of the salve on, went to bed. I regularly applied it before I got dressed, and then I put some more on at night before I went to bed. And I must say, though, being in the construction and building industry, I've had many falls and injuries and stuff, and I figured I'm going to be laid up with this for a month. We drove home. I think it was 3 to 4 days later. I continued applying the salve, and I would say within a week, I was getting around pretty good.
Wow.
Yeah, it definitely helped. It most definitely, and so I understand that there's a lot of healing ingredients in that salve that can actually penetrate in
Mm-hmm.
to a to to really alleviate the inflammation that's inside during an injury like that.
Yeah. Yeah. I don't have all of the specifications for, as a matter of fact, we might actually, in later segments, we might actually interview some of the people from the company who make the product, and they can tell some of the details of, of the ingredients and what they do and how they, because my understanding is more than just a pain relief. There's actually
Mm,
healing. There's
healing.
compounds and other ingredients in there that literally heal as well as pain, relieve pain. And that is one of the reasons it works so fast. One of them I know is comfrey.
Mm-hmm.
And that's a big one. I know that for a fact because anybody can look it up. But comfrey is an ancient name for comfrey is called the bone healer,
Aha. Yeah.
and it gets that name for a reason. But did you said now I know you take the Apollo oil as well, like when you
Well, yeah.
road
I,
trips. Did
I,
you have
I
that
when
with
I
you?
traveled, especially, I always bring the oil because it helps relax me, and it helps me to sleep. And I have a tough time sleeping sometimes when I'm on the road and traveling. So every little advantage I can take that's going to help me get that rest and get a good night's sleep, because particularly like if I'm leading a tour, I got to be on all day, and for me to do that effectively, I have to have a good night's sleep.
Right.
So I always bring the oil when I travel, and I'm now, after this episode, I'm like, okay, I'm always going to have the salve with me too. Since the year 2007, a series of impact proxies have been discovered at the Younger Dryas boundary, whose closest analog appears to be the KT boundary of 65 million years ago. The possibility of a major cosmic impact so recent in Earth history has given rise to one of the great scientific controversies of our time, one whose far-reaching implications are only just beginning to be grasped. So in the year 2007, a group of scientists led by Richard Firestone with the Nuclear Science Division of Lawrence Berkeley National Laboratory published an extraordinary article in the Proceedings of the National Academy of Sciences. In this article, they presented evidence that in the recent geological past, a mere 12,900 years ago or so, Earth was the victim of a major assault from space. The most likely culprit in their analysis was a comet. Now, if you would like to read the original groundbreaking article, see Firestone Richard B. et al. In 2007. The title of the article is Evidence for an Extraterrestrial Impact 12,900 Years Ago that Contributed to the Megafaunal Extinctions and the Younger Dryas Cooling. This article appeared in the Proceedings of the National Academy of Sciences, Volume 104, page 16,016. Okay? The Proceedings of the National Academy of Sciences is public access, so you should be able to find the entire article available for free download on the web. Simply type in the title and you will be taken right to it. Go to Google Scholar. I haven't tried just regular old Google, but Google Scholar will certainly get you there. You can then download it, print it out, read it. The article has many valuable graphics and images of the discoveries made by the Firestone team. So the Younger Dryas impact hypothesis, as it has come to be called, is proving to be one of the most controversial scientific ideas of our time, not unlike the Cretaceous Tertiary impact hypothesis when first proposed by Walter Alvarez and his colleagues back in 1980. just as that idea generated extensive discussion with proponents and opponents of the impact hypothesis making their strongest arguments. So is the YD, or Younger Dryas impact hypothesis, generating vigorous debate, which is just as it should be in the practice of science. However, in this case, the impact idea has been met with a level of acrimony and disdain that considerably exceeds that of the earlier KT boundary debate. I'll get back to that because it is important to understand why the idea is so controversial. But basically, for now, the Younger Dryas impact idea posits that an extreme climate spasm that occurred at the very end of the last ice age, an event whose cause, at least up to now, has been an ongoing mystery, was triggered by the impact over North America of one or more cosmic objects, most likely a comet or its debris. This putative comet has been christened the Clovis Comet, after the name of a North American Paleo-Indian culture that virtually disappeared from the archaeological record at the very onset of the Younger Dryas. I will mention that the Younger Dryas, the fact that you call it the Younger, implies that there was an older Dryas. And what distinguishes these is they were initially applied to climate regimes. The Younger Dryas is named after a polar wildflower called Dryas octopetala, an 8-petaled flower that loves the cold. So in Northern Europe, you had the older Dryas, and Dryas octopetala was proliferating, and then it disappeared for a millennia and a half, roughly, and then it came back again, which seemed to indicate that the climate went from cold to warm, because Dryas octopetala does not like the warm climate, the warm weather, and they are going to quickly pack their bags and head north to where they can find the cold that they love so much. So you had the older Dryas and then the Younger Dryas. Now, the Younger Dryas appears to have been the more severe of the two, but in any case, since the idea was first presented in 2007, evidence both pro and con has accumulated. However, as of this writing, the case for impact has grown increasingly plausible, and with the publication of recent rigorous investigations, the evidence in favor of an extraterrestrial impact at the inception of the Younger Dryas now appears to be the most likely explanation for the extreme and inexplicable events that characterize the rapid transition of the planet out of the Great Ice Age. To reiterate, among the specific events associated with that transition, events not yet adequately explained are: 1. The rapid extinction of nearly half the world's large mammal species. 2. A sequence of severe temperature fluctuations up to 10 degrees centigrade or more in only a few years. 3. Unimaginably huge meltwater floods associated with the melting and disappearance of the great ice sheets. 4. Profound global ecological reorganizations. 5. The disappearance of the ancient North American Clovis culture. Before I elaborate upon the discoveries of Firestone and his colleagues, I should describe several earlier discoveries that led up to the interest in what we will hereafter call the Younger Dryas boundary, or YDB. In the year 1993, after 5 years of drilling, 2 scientific teams, one American, one European, succeeded in extracting 2 ice cores that reached from the summit of the Greenland ice sheet to bedrock, a total down core length of more than 3,000 meters, nearly 2 miles. The American project, with the help from Denmark and Switzerland, has been referred to as GISP, G-I-S-P, short for Greenland Ice Sheet Project. The European counterpart is called GRIP, for the Greenland Ice Core Project. An analysis of these ice cores, revealed startling information about how severely and how rapidly Earth's climate and environment have changed in the past. Most especially was this true for the period under discussion, the termination of the Great Ice Age centered on around 13,000 years ago. The motive for undertaking this heroic and highly complex project on the part of these two teams was for the purpose of confirming yet earlier evidence that something extreme had happened at the glacial interglacial transition, as well as to assemble a much longer timescale record of global climate change. One of the leading lights of the earlier work was Wolfgang Helmut Berger, an oceanographer, geologist, micropaleontologist, and emeritus professor at the Scripps Institute of Oceanography. He recently passed away, well, not so recent, but he passed away in August of 2017. Berger had a keen interest in climate change, which led him to the study of the cores extracted from the deep ocean floor. These cores can yield up considerable detail about changing conditions in the ocean, and that is, in turn, a reflection of the changing climate. In an article published in 1990 called The Younger Dryas Cold Spell, A Quest for Causes, Berger commented that, quote, deep sea record shows evidence of abrupt climate change centered on the last deglaciation and resulting in a severe cold spell known as the Younger Dryas period. The origin of this climate catastrophe is not known, unquote. To provide a better context for understanding this quote, I should explain that the deepest, coldest period of the last ice age lasted from about 20 or 22,000 to about 15,000 years ago. After that, the climate began a period of gradual warming consistent with natural forces involving the changing geometries of the Earth-Sun relationship. These are called the Milankovitch forces, and it has to do with the angular tilt of the Earth's axis, the shape of its ellipse, and how far the Earth is in its distance from the Sun during the course of its orbit around the Sun, because it actually varies between 92 million something and 94 million something. So these factors interacting together can cause the amount of solar heat reaching the surface of the Earth to vary, so that sometimes the forces will cancel each other out and it'll be neutral. Sometimes the forces will combine in such a way that the planet cools, and at other times they will combine in such a way that the planet warms. Now, somewhere around 14,500 to 15,000 years ago, these natural forces, called the Milankovitch forces again, were conducive to planetary warming, and that's what we saw. The planet was warming, and it did this for a couple of thousand years. And during this time, the glaciers shrank back to maybe 85 or 90% of their peak volume at the late glacial maximum. And this gradual warming was suddenly interrupted around 12,900 years ago, and the planetary climate lurched back into a full glacial mode. The warming period is generally called the Balling-Allarod. There was two substages in there, the Balling and the Allarod, but it was this time that most of this gentle gradual warming was taking place. As the massive ice sheets began a steady retreat from their most advanced positions, they lost perhaps 10 to 15% of their total mass during the next 2,000 years of the Balling-Allarod. Now, as previously frozen land began to thaw along the periphery of the ice sheet, both animals and people began to migrate into the newly uncovered territory. It was during this interval that the so-called Clovis culture appeared on the scene in North America. However, very close to 12,900 years ago, or shortly thereafter, this phase of ameliorating climate came to a sudden and catastrophic end. The global climate rapidly reverted to conditions of full glacial cold. When the Greenland ice cores became available for study in the early 1990s, what had been implied about rapid climate change in earlier research was convincingly confirmed with the highest resolution record then available. The records in these ice cores literally revealed environmental change on a year-by-year basis, due to the accumulation of annual snowfall and its conversion under pressure into layers of glacial ice. Much as tree rings provide an annual record of changing climate, so do the layers within ice cores also give you a year-by-year introspection into climate change and environmental change, at least until you get down into the deeper parts, and then the layers tend to get obscured. However, there's electrical techniques that can detect changes in dust level and so on that is helping to decipher the more obscure layers in the deeper parts of these ice cores. One of the leading scientists involved in the work of extracting and analyzing the ice cores was Danish paleoclimatologist Willy Dansgaard. He was the first to realize that changing isotope ratios of deuterium and oxygen-18 found in glacial ice could be used to determine past climate and temperature. So, in terms of these isotopic ratios, you've got a lighter oxygen, which is oxygen-16, where you've got 8 protons and 8 neutrons, and then you've got oxygen-18, which is a heavier isotope. And during warm times, what happens is, as the temperature changes, so does the evaporation regime from the ocean respond to that by changing. So one of the things that happens when you have higher temperatures, you have more energy available to extract more water out of the ocean basins. When the climate cools, there's not as much energy, and what happens is the heavier oxygen molecules are preferentially left behind. So when this evaporated moisture precipitates out as snowfall, the snowfall is enriched in the lighter oxygen-16 than the oxygen-18. Does that make sense? So now you've got the oxygen-18 embedded in the glacial ice. Now, when that glacial ice melts, the lighter oxygen floods back into the ocean basins, and that has changes in the chemistry of the ocean water. I'm not going to get into that in this discussion, but I will talk about that at some point. So anyways, as Dansgaard analyzed the changing isotopic ratios, he came to understand that earlier concepts of rapid change implied by ocean bottom cores and previously drilled ice cores were not merely the result of a sampling artifact, which some of the assumed or some of the apparent appearance of evidence within the ice cores that would seem to imply very rapid climate change or very catastrophic type events, they were being dismissed as being simply sampling artifacts. But these new cores demonstrated convincingly that these catastrophic events preserved in the ice layers were disturbingly real. In one generation, the thinking about the pace of climate change and about the timing of glacial interglacial transitions had changed drastically. No longer was it a matter of many thousands of years or even hundreds of thousands of years, but as Dansgaard explained in a seminal article that appeared in the journal Nature in July of 1993, the tempo was much faster than anyone had imagined. In the Nature article, he commented that, quote, recent results from 2 ice cores drilled in central Greenland have revealed large, abrupt climate changes, suggesting that climate in the North Atlantic region is able to reorganize itself rapidly, perhaps within a few decades. Let's think about that. Large, abrupt climate changes within a few decades. This was the reality that now had to be confronted and integrated into any evolving model of global change. Because previous to that, it was assumed that it was thousands of tenths of thousands of years involved in the deglaciation process, that it was a continuous process, that it was relatively smooth. And now what is showing up is evidence that was anything but, that there were periods of rapidly accelerated melting that then would have required an input of energy from some source, which was at the time not known. So as research continued, the intensity and rapidity of these global change events grew yet more extreme, even as the focus of climate change research was being directed away from the study of natural variability to focus exclusively on the roles of human-caused climate change resulting from human consumption of fossil fuels. Prior to the extraction of these two ice cores, earlier core samples, along with cores taken from the ocean floor, revealed a dynamically changing environment far beyond what had been imagined a generation before. To repeat the comment by Wolfgang Berger, the deep sea record shows evidence of abrupt climate change centered on the last deglaciation and resulting in a severe cold spell known as the Younger Dryas period. The origin of this climate catastrophe is not known. Unquote. This is 1993. Okay. Berger was not exaggerating when he called it a climate catastrophe. And the origin of this catastrophe was not known in the early 90s when Berger wrote. Nor is it really known with certainty as of this podcast episode right now. However, major fingerprints of a culprit have been discovered in the interim, and to that I will return directly. In reference to earlier Greenland ice cores, the weekly journal Science News reported that, I quote, ice records drilled previously indicate the climate can sometimes fluctuate with surprising speed. In particular, studies of the JISP-1 core drilled from 1979 to 1981 in southeastern Greenland suggest that the North Atlantic region warmed by a striking 7 degrees centigrade in half a century. That drastic warming far outpaces what the world is currently experiencing, unquote. Quoting James White of the University of Colorado at Boulder, a participant in JISP 1 and 2, this is what he says. That really surprised us, that things could happen so quickly, says James White. And this is from an article that appeared in Science News in 1991 called Tales from Ice Time. Page 168 if you want to go track it down. Recall again the quote by Willie Dansgaard, one of the chief scientists studying the ice cores, who exclaimed that the climate was able to reorganize itself perhaps within a few decades. The earlier results suggesting a half century for a 7-degree warming had been difficult enough to believe. Now, higher resolution records were indicating considerably less than half a century for a climate warming that was in effect the temperature difference between a glacial and an interglacial age. But further studies narrowed the time frame even further. James White, quoted above, authored an editorial in Nature in July of 1993 after continued study and analysis of the message of the ice cores. His incredulity at what he found is apparent, and I quote, "The new ice core results bring rapid climate change to our doorstep. Changes up to 10 degrees centigrade in a couple of decades or perhaps in less than a decade appear possible in interglacials." Unquote. The data now revealed that the climate was able to change a full 10 degrees centigrade or 18 degrees Fahrenheit in perhaps less than a decade. White remarks, and with respect to that realization, quote, "The speed with which the climate system can shift states gives us pause," unquote. As indeed it should. Consider that the modern concern over global warming is based upon a 1 degree centigrade warming, or a degree and a half, depending on whose data you use, since the mid-19th century. As the 1991 Science News article just quoted, states regarding the ancient warming, that drastic warming far outpaces what the world is currently experiencing. Keep this fact in mind when you hear or read someone, some journalist, or some paid-off scientist arguing that the current global warming rate is unprecedentedly fast or severe, which you no doubt will if you engage in any kind of inquiry or dialogue into the subject of modern climate change. As further investigations of the ice core data continued, the picture that emerged was no less unsettling. Willie Dansgaard co-authored another paper discussing the longer view of climate change that was emerging from the ice core studies. He reports that, quote, "We find that climate instability was not confined to the last glaciation, but appears also to have been marked during the last interglacial and during the previous glacial cycle. This is in contrast with the extreme stability of the Holocene, suggesting that recent climate stability may be the exception rather than the rule." Now, keep in mind, he is talking about 100% completely natural climate change that is not the result of humans burning fossil fuels and driving SUVs and building buildings out of concrete, okay? This was from a paper that appeared in Nature July 15th in 1993. The title of the paper was "Evidence for General Instability of Past Climate from a 250,000-Year Ice Core Record." The last interglacial in this case was a period that occurred between roughly 130 and 115,000 years ago and is frequently considered to be analogous to the current Holocene epoch. It is often caused marine isotope stage 5E. And we'll talk about what we mean by marine isotope stages in another podcast. Now remember, when referenced to the Holocene, that it's the geological epoch comprising the last 11,600 years, according to the most recent dating, the last 11,600 years of post-glacial warmth, the one in which we currently reside, the one which has seen the rise of history and the rise of civilization after quite a number of aborted starts. So the team of scientists whose responsibility was the analysis and reporting on the ice core finding were called the Greenland Ice Core Project members. In the same July issue of Nature, they contributed a paper in which they discussed various aspects of the emerging picture. They examined the ice core record to try to understand when the previous interglacial period, again called the Eemian, occurred, how long it lasted, and how it ended. As they perused the long record going back more than 150,000 years, they began to realize the unique nature of our modern epoch. In that regard, they commented, quote, "Given the history of the last 150,000 years, the past 8,000 years has been strangely stable." This was authored by the Greenland Ice Core Project members in a paper published in 1993 with the title "Climate Instability During the Last Interglacial Period Recorded in the Grip Ice Core." Now, strangely stable. That's an interesting way to put it, to say the least. James White, who I quoted earlier, he commented upon the implications of these findings, and these need to be pondered by the whole human race as a species, in my opinion. But this insight, this question that James White raises is essentially being ignored because it's been suppressed in effect through deliberately ignoring the results showing, demonstrating conclusively that natural climate change has occurred over and over and over again on any scale that we care to measure. Okay? But we are now supposed to believe that only humans cause climate change. And if you don't believe that, I would suggest that you go into the literature of the last 10 years, go into the publications of the IPCC, the Intergovernmental Panel on Climate Change, listen to the progressive interests in Congress, listen to the progressive interests, the talking heads that have been conscripted to push this narrative out, and you'll hear them saying the same things over and over and over again. Every weather event is now the fault of humans. We're just getting through the horrible fires at the Palisades region in LA, and of course the same suspects are lining right up to blame this on human-caused climate change. I think we need to have another discussion about an update on our wildfire discussions we had in earlier episodes of Squaring the Circle, where I take a deep dive into the phenomena of wildfires and why humans' influence primarily is this, not the fact that we're injecting carbon dioxide into the atmosphere, but the fact that our infrastructure, the Maui fires in Hawaii were almost certainly caused by power lines blowing down. They've already now discovered or caught at least several arsonists, humans who have deliberately lit fires during these times of catastrophic conditions, whereby, for example, the Santa Ana winds, which were blowing so belligerently and causing the fires to spread so rapidly here during the last few days and the last weekend. Arson is a major factor, as it's turning out. Okay, so anyways, keep all this in mind as we consider this quote from James White, as he was looking at these findings, the story revealed in the glacial ice cores. And he says this, quote, "We humans have built a remarkable socioeconomic system during perhaps the only time when it could be built, when climate was stable enough to let us develop the agricultural infrastructure required to maintain an advanced society. We don't know why we have been so blessed. I will repeat, we don't know why we have been so blessed. But even without human intervention, the climate system is capable of stunning variability. Again, even without human intervention, the climate system is capable of stunning variability." White makes an important point that seems to be lost in the contemporary discussions of climate change when he states that the climate system is capable of stunning variability and that this variability can happen even without human intervention. To this day, except for the fact that they were not being caused by human activity, we still do not understand what was driving these extraordinary climate changes at the end of the last ice age, although a solution may be imminent. At some 24 archaeological sites around North America, going back to the 1990s, there has been studies conducted on a black carbon-rich layer, usually only a few inches thick, that marks this major transition from glacial to interglacial, and it defines the lower Younger Dryas boundary where this sudden climate shift occurred. Below this layer are to be found the fossilized remnants of the great extinct megafauna, but not, or rarely not, above it. Below this layer, but not above it, are to be found artifacts and tools representative of the late glacial culture that was contemporary with the still extant megafauna, the so-called Clovis culture. And the Clovis people were named after a town in New Mexico near where human tools and spear points were first found in association with several species of mammoth and other extinct animals. The black matte layer that marks the Younger Dryas boundary, it also marks Earth's sudden plunge back into full glacial cold after several thousand years of global warming. Due to its widespread presence and association with a boundary stratum marking major climatic, cultural, and biotic change, the black mat drew the attention of a number of scientists who were seeking to understand its significance within the context of global change. What they discovered has opened the door to a major evolution in our understanding, not only of changes within the order of nature, but changes that compel a complete reconsideration of human history. For lying beneath and within this layer were found the fingerprints of a mighty cosmic event, an event that separates our modern world age from the archaic age that became as extinct as the great megafauna. Thank you for joining me in this episode of Squaring the Circle, and I look forward to our next meeting together. Thank you. I'm Randall Carlson.